Good morning, students. Welcome to the physics class. Today we are going to study about one of the important point. So that is termed as an what here? The law of conservation of momentum. You already know the Newton's third law of water motion. What does the Newton's third law of motion says? Newton's third law of motion says, okay, Newton third law of motion. Third law of motion. For every body, for every action, there is an equivalent and opposite reaction. So this is what we termed as an what here? The Newton's third law of motion. You already know that here is a one body. Let us call it as an A, and here is another body. Let's call this as what here? The body B. The force which is exerted by the body A on what here? The body, the B. Then I can able to say this one is F1. Why I am saying F1 means this is the force exerted by the body A on water on B. In the same manner, the force which is exerted by the body B, is let us call F2, on water on A, then I can able to say, so this is termed as an what here? F2. Therefore, according to the Newton's laws of motion, what we say is F1 is equal to minus of what is that? F2. Okay, therefore, for every action, there is an equal and also what is that? Opposite reaction is there. So we will always used to say is like this: F1 is equal to minus of what is that? F2. It means that in opposite direction. So the minus sign is shows the what here? In opposite what? The direction. Equal and opposite. So this particular law leads to what here? Law of conservation of what? The momentum. Before we go into study about the law of conservation of momentum, let us study the what here? The simple one with the example. Okay. So here we have law of conservation of what is that? Momentum. We have a law of conservation of momentum. Okay, this is the law we recover to what here? Study today. Now let us consider, here we have the one body. This is the body we have. Mass of this body A is considered as what here? M1. And it is moved with the velocity of what here? Initial velocity. Let us call that as what here? U1. U means you already know that this termed as an what here? Initial velocity. Then there is another body. Here is another body. Let us consider this body is having a mass is M2. And this the body is B. It is also moving in the same direction. Let us call it as a what here? Its velocity is what here? u2, that is termed as what is the initial velocity of that body. Now these bodies are moving like this, then it collides. Okay, whenever it collides, whenever it touches each other or collides each other, then what happens? This body collides with this one, means so it is during what here? Collision. This is the M1 and this one is M2. This body is A and this body is the B. It collides. After it collides, the both will move in the same direction with a what here? Final velocity. With what a final velocity. Let us consider this is M1, body A. It moves with the final velocity. How to write the final velocity? U is considered initial velocity. So V is considered as what here? The final velocity. What is the final velocity of the body A? It is nothing but a V1. And the body B is moves with the what here? The velocity M2 here. So the body moves with the velocity is V2. Okay. So this is before collision, during collision, after collision. After a collision, it will reach the final velocity. Whenever the body is moving like this, both the bodies, then hits, then once again it will move. Just you are playing with the what here, just you are playing a carom. When the striker is the hits to the what here, the pawn, then what here, both the bodies will start moving like this. So here, I want to know about the force. I want to know about the what here? The force of the body A on what? The body B. Body A on what? The body B. Let us consider the force exerted by A on B. Force exerted on A, by A. A means this body. On which body it is exerting? On the B. By A on what here? B. By A on B. So force is nothing but a what here? F1 or 2. Just think about this. It is nothing but a what here? Force F1. Let us consider this is called the F1 is equal to mass of the body, mass of B. Mass of what is that? B. And also what is this? The velocity of that body B. We have to consider both these things. So, acceleration of the body, B. Acceleration. So, into acceleration of the body. You already know that according to the second law, the force is equal to mass into what is that? Acceleration of the body. So therefore, the mass of the B, acceleration of the body. Now what we will get? F1 is equal to mass of the body B means what here? M2. Yes, you see, M2. Into acceleration of the body is nothing but what here? I can able to say. What is the acceleration? Acceleration is the rate of change in a what here? The velocity of that body. After its collision, it reaches to the what here? The V2. V2 minus of what is that? U2. So therefore, the V2 minus of what is that? U2 divided by what I can able to say? There is a change in what here? The time second or t seconds. Therefore, we will call it as what here? So this is considered as what here? The first equation. Similarly, force exerted by B on A. By B on what here? A. So therefore, what happens here? The F2 is equal to mass of A into acceleration of what here? Yeah. Therefore, F2 is equal to m1 into v1 minus u1 divided by what is that? That is considered as what here? The second equation. It's the same thing. Okay, there's no doubt about it. Now, according to the third law of motion, according to third law of motion, according to third law of motion, what the third law of motion says, you just see here, F1 is equal to minus of what is that? F2. So therefore, F1 is equal to minus of what is that? F2. So what is that F1? So we can take like this, M1 V2 minus of what is that? U2. So therefore, M1 into V2 minus U2 divided by 2. That is equal to minus of what is F2? Let us write this one. M1 into V1 minus U1 divided by. Simplify this particular thing. What you will get? You will get is M1 U1 plus of M2 U2, that is equal to M1 V1 plus of what is that? M2 V2. Just you simplify this one and then make some arrangement here. So what you will get is. So what is the conclusion of this particular thing? Okay, this is termed as an what here? The initial momentum. Mass into velocity, mass into velocity, mass into velocity. It means that what? It is a nothing but a what here? Mass into velocity is nothing but a momentum here. Okay. So therefore, this is initial momentum. This is termed as an what here? Final momentum. So then how you can state the what here? The law of conservation of momentum. The law of conservation of momentum states that total momentum, this is the total momentum before what here? The collision is equal to the total momentum after collision. Okay. So this is how the law of conservation of momentum is states. So this is one of the very important concepts. Okay. So we have a number of examples on this. Okay. So this is all about the law of conservation of what here? Momentum. Okay. So thank you very much for watching this video. Thank you.